Hi, this is Justin Crooks, AI7SG, and I'm getting ready to build a couple of Yagis for testing my AOA direction finder. Got my PVC pipe Lego set out and built a little structure. This should be able to give us room for a reflector element and a driven element. And hopefully I'll be able to catch a weather station on VHF that's about the closest to the 2-meter band that I know I can test for. The weather station that we're going to be direction finding is about 67 miles away. So even though it's 1,000 watts output, the signal is going to be fairly weak. Well, may not be pretty, but it's tuned to greater than 20 dB return loss at 162.55. One thing I like about using copper tape for these is it's super easy to tune. Just rip off a little tape until the resonant frequency is right, and you can even add tape if you go too far. The other nice thing about copper tape is it simulates some really wide wire, so you can actually get a lot more bandwidth out of simple antennas like this. I've got it hooked up to my trusty SA44B, which I designed, by the way. And we're just looking at that 162.55. I know it's kind of hard to see in daylight. All right, now we got the analog DMOD running, so we can see there's actual weather data on this frequency with this antenna. So I think we're ready to try our direction finding system. All right, so here we are up and running. We have 2 antennas set up, and it is demodulating the audio. The audio quality leaves something to be desired, so obviously a little bit more work to do. And you can see my line of bearing. It's kind of hard to see in the sun, but bouncing around a little bit. And as I move the antenna, you can see now it's moved by several degrees, even though I just rotated the antenna maybe 4 degrees. So definitely super sensitive, and I'll have to check on the math and make sure I'm not doing something wrong. Let's see, I moved the antenna a little bit further, and you can see now the angle of bearing is reading quite a bit over there. If you're curious what the code looks like for the Raspberry Pi Pico 2, essentially I set it up so there's a couple of ADC channels for receiving that IF data. I'm running them at 384 kilohertz between the two, so that's 192 kilohertz per channel in a round-robin acquisition. And I'm using the FIFO just to simplify the code. That way I can just grab 4 samples at a time. Starting with channel 1 so that the phase is always consistent. And we get the data. Because we don't have the bandwidth to put all that data across the USB, which is just a full-speed USB pipe, I'm going to FIR filter and then decimate by 2 so that we're getting each channel at 96 kilosamples per second. I am using the HSTX port, the high-speed transmit, to generate the first LO. So basically that's just going to be outputting 2 in-phase square waves to my first mixers. Then there's also going to be a second LO needed. Because they have access to a fractional divider, this really simplifies the process. And basically all I have to do is the spurious generated by that fractional divider. I have to ensure that the frequency is outside of the audio passband. On the PC side, I'm using WX widgets because it's a fairly simple way to build GUIs that will work cross-platform. Although this is a Windows-only project for now, it would be fairly simple to convert it to Linux once it's done. And I'm using the Intel Performance Primitives library for most of my digital signal processing. It's just a really handy and free way to get some powerful SIMD instructions for doing things like FIR filters, IIR filters, complex multiplies and tunes, FFTs, etc. So even though my sub $10 radio isn't the best radio in the world, it is able to receive a signal over 60 miles away, demodulate it to audio, and compute a line of bearing. Once I add a compass, that will make it just that much easier to get an accurate line of bearing. And hopefully it will make fox hunt fast and fun. This is Justin Crooks, AI7SG. Like and subscribe.